Hey everyone, day 10 of Advent of Code 2025 today. We're in that final stretch, last 3 days, and a bit terrified. I mean, after yesterday's problem, kind of scared to see what the last 3 days will hold. It's a bit hard to judge the difficulty scaling, obviously, because, well, every other year had a vastly different amount of problems. But, I mean, in previous years, stuff like day 20 often was the hardest, which is roughly what day 10 feels like it should be. So a bit nervous for sure. I guess today I will guess it's a. What kind of problem will it be today? I have not been very good at this. I'll just guess. I got nothing. I'll guess that it's a problem that requires dynamic programming or some sort of memoization. Yeah, not a very exciting guess, but we'll see how it goes. I did also end up doing the day 9, but it's probably best that I didn't record it. The initial solution I'd come up with for part 2 took 33 minutes to run. I mean, luckily it was right at the end, but it was a disaster. I mean, the basic logic is here. I basically need to check if a point is in a loop by first checking if it's on any edge and then doing, I think it's called ray tracing, to find if it's actually in the thing. Then once you're there, you just have to check every rectangle and check the border of every rectangle to see if it's in there. Okay, we'll start with day 10 now. But yeah, day 9, quite a doozy. Okay. Ooh, that's going to be kind of interesting to parse. Let's use space as our regex. Okay, what is the problem? We have indicator lights, but joltage requirements. One machine per line. Each line contains a single indicator light, one or more button wirings, and one or more joltage requirements. Okay. To start a machine, its indicator lights must match those shown. Okay. So everything starts off where dot is off. So everything starts dot, 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 dot. You can toggle the state by pushing any of the buttons. Each button lists which indicator lights it toggles. Okay. So button wiring schematic 034 means each time you push. Okay. Cool. The fewest presses to turn on the machines. Okay. Well, I understand the problem. I don't know if I understand how to do it, but at least I understand the problem. So we have, let's just start creating classes. Class lights. We have, how do I want to represent this internally? Probably as a Boolean array? But there might be intermediate states. I'm going to use an int array instead, just in case. And then we'll make sure to make it work. Let's see, public lights. Kind of weird to have a plural in an object name, but it's multiple lights, right? So I feel like it's fine. And then what we can do is lights equals L dot. My goodness, I've forgotten how to do everything. Dot length. There we go. And then for int I equals 0, we now just check against dot. So what is it? Lights not sub-0 equals so we do char at. So L dot char at I equal dot. If it is, then we set it to 0, otherwise it's on. Cool. So that's lights. actually going to preemptively do equals as well. What this will be is just it's just a simple check through all the lights, like element by element check. Cool. Okay, now how do we actually parse this input? So the first one is always that, so we can have lights, yeah, equals new lights, lines of 0, cool. And then the rest are buttons, so let's have a way to represent buttons. Honestly, I think internally they're just going to be a list of integers. How should I give... I think it's just the same thing. Let's just do a single thing. We want to split on commas. Actually, first let's substring it. Let's do b equals b dot substring 1 comma b dot length minus 1. Then we want to split it out. What's the best way to do that? B dot split on comma? And then for string essence split, buttons dot add, the good old inner dot parseInt. Cool. Alright, I should here. Just need to declare it somewhere, or initialize it, sorry. Okay, so now I have that, so I can just do for int I equals 1, I less than line dot length minus 1, I plus plus. The reason for the minus 1 is because the last one's always joltage. We want a list of buttons. We can do buttons dot add new button. It should be button, I think. New button. Let's try that. Line sub I, or line at I. Okay, so now we have all the lights and buttons. Let's create a helper method, which basically just takes in some lights and a list of buttons and returns the minimum. Cool. Now, of course, how in the world do we do that? I mean, you can just try all the buttons, right? The issue is there can be a lot of buttons. Like it's exponentially scaling, right? The number of buttons to try. I mean, we can give it a shot. I think it's possible to at least attempt it, right? Yeah. Yeah, it should be possible. All right. So I'm actually going to do the problem in reverse, I think. I'm just trying to think if that's any different, because I ideally I want to start this and then end on the null. Okay, so 0, 1 would turn what? This one and this one on. Turn this one off, this one on. Like, is that equivalent? Like, imagine here, yeah, I think it's equivalent, right? Like, going both ways should be equivalent, because pressing 2 buttons toggles it. Yeah, okay. The thing is, this is Python written all over. This is a Z3 solver would immediately solve this, because these are just equations, effectively, right? Like, that's what this is. Okay, but I don't have a Z3 solver. I don't even know if an equivalent in Java, unfortunately. So we're gonna solve it with the dumber coding way. So basically what we can do is, I guess, first there's the sort of null lights. So we should have that public boolean is done, where we just go for integer I in lights. If I not equals 0, return false, otherwise return true. And then we can do if lights dot is done, return attempt. No, return 0. Otherwise, long answer equals 0. And then for so actually I think I want 2 lights. We also want a way to instantiate from another light. So in this case, we just have it be other light dot lights. What the? Oh yeah, dot length. And then for dot equals 0, we just copy everything over. Yeah, it's a manual array copy. It's all good. Okay. So now for button in buttons. Integer dot max value. Okay. Basically, what I want to do is answer equals math dot min of current answer and helper with lights dot apply button buttons. Oh no, +1. Right. So now we have an apply. And what we do is we toggle it. So for what is it? Yeah, for integer b in button dot buttons. If lights b equals 0, lights b equal 1, else lights b equals 0. Oh, right, I do need to, wait, what? Apply. Oh. Yeah, let's do this. Lights, new lights equals new lights, lights, dot lights. Wow, that is a horrendous naming schema. New lights dot apply button, and then we just do new lights here. What a phrase. Lights, new lights equals light, new lights, lights, dot lights. Stack Overflow. Wow, that was very fast. Wait, at line 26. Isn't that a crazy spot to overflow? Why is this overflowing? Is that a 2-string, I guess? I think arrays are fine. Oh no, arrays are not fine. Let's do arrays dot 2-string. Curious what's happening here. Oh, I know what it is. It's because it goes to the first button, toggles it, and then it goes, and then just infinite loops. Okay, so we do need to cache the button somehow. Okay. Actually, this is a great time to build in a hash code, I guess. And our equals should be object, I guess. Had to modify equals a little bit. Now for hash code, what we can do is hash equals 0, and then for, what was it again? Yeah, light. For integer I in lights, hash plus equals I, hash times equals 2. Something like that should work, and then return hash. Cool, just want to make sure we have everything done so that dot contains works properly when we do it. So now what we can do is have a hash set of lights. Already seen. So if already seen dot contains new lights, sorry, if not that, then already seen dot add new lights. Okay, we've now cached it. I have no idea. That seems like a very high number. Yeah, okay. Let's try the example. Holy moly. Yeah, that seems a little bit off, huh? What is that? 6 billion presses? What is the actual answer? 7. Okay, what the heck? Wait, there's no, we're printing out like 10 things here. How are we possibly getting, what the, oh, we're getting integer on max value. Well, that's not great. Why would it do that? So 3 is the fourth light, yeah. And then try itself again. Oh, you know what? Maybe I should start with lights. Can I not do that? Alright, fine. Set. So we don't do the dance. So then there's 1, 3. So it tries 1, 3, yeah. I think we should also, I guess, add in a sequence. So like list, like new array list integer. Basically we have list integer button sequence. So we do this is quite tricky. I mean, if part 1 is like this, I am terrified for part 2. We do list new sequence. Oh my goodness, can I spell the word sequence? It's a new array list. Let's add all of button sequence, and then add, oh wait, what button do I have? Maybe I should just make it a list of buttons then. Okay, now we need a button toString, but that one's pretty simple. Public string toString return buttons.toString. Cool. Okay, so we tried 3 a bunch of times. Didn't work. So now we went on to the next button. Why did we not go on to the next button? Like, what's going on here? For button and buttons. What the heck? Okay, wait. I'm getting rid of these 2. I just want to do the first one right now. Oh, we need a separate set. Yeah, this is not the right already scene. We need set lights new scene equals new hash set new scene dot add all already scene new scene dot add new lights. At all. And then we use new scene instead. Well, at least it tried hard. Can't fault it there. What is going on here? Lights is null at the start? That doesn't make much sense. Actually, yeah, what in the world is going on here? Am I misunderstanding the line itself? How in the world are you parsing the line as... Oh, you're not. It's just this is overflowing. Whoops. 1 second. Wait, what in the... How are there... Oh, I'm not... Okay. Wait. I need to do this for lights as well. This makes a lot of sense. It obviously will never work. Because it can't hit the last light. And the last light is always on because of the bracket. Okay, let's try again. Okay. That was silly. Cool. Why is it frozen? Huh? 0, 1, 0, 1, 0, 0, 0, 0. That looks correct. Oh, I stopped doing this line, I see. I'm guessing it's just super slow, but let's confirm. Dang, is it really that slow? I guess it's possible. Huh. Okay. Well, that seems infeasible. We can try speeding it up a little bit. What we could do is return some light that is not already on. So public int off light. So what this does is it'll go through the things until it finds one, on light. Until it finds a light that's on. Alright, so then we only want to try things that include that. So and button dot contain button dot buttons dot contains dot onLight. That apparently did not speed up anything. Well, first of all, does it work? Okay, it does. It's just that slow, huh? Even with some optimization? Like we're always now only trying. This seems ridiculous, no? I mean, how big is this state here? 1, 2, 4, 5, 6, 7, 8, 9, 10. 2 to the 10th is like a million. This is crazy. Maybe I need a better cache. Like, cache a list of... Ugh, how do I do this in a smart way? Yeah, wait. We can build the cache better. Let's do a map of light to list of button. Because this means if we've seen the same thing with the same button, then we're good. So that's what we can do. If already seen dot get or default we need to turn a button. No. List of buttons. If already seen that get or default. Nope. Dot equals no. Dot contains button. Then we want to not do any of this stuff. Just directly add already seen dot add new lights, comma this thing. No. So list seen buttons equals this thing. And then seen buttons dot add button. And we put it back. And we stick with already seen. So now we build the map directly. Oh. Okay, that's an answer. I'll put it in and then I'll try it. Dang, okay. Let's try on the sample. Oh boy, okay, does not work on the sample. That's a bit strange, no? Because you'd think that if we're in this position, oh, wait. It's not, oh gosh, this is a list of buttons? Because it's like, if we've seen, no, that's not quite it either. The problem is just because we've seen a position, but like a certain button could still be the right move, it was just used in a prior sequence. How do I account for that? Maybe I should just write an equation solver. That feels like it'd be almost easier. No, I don't want to really learn Python Z3 solver yet. I'm curious, how hard is the second part? Pretty dang hard. Okay, that's unfortunate. Well, I'm really a little bit stumped. The efficiency here is just not quite there. Oh, one thing I could do is cache. Yeah, okay, wait, let's go back. I think we go back to the old setup. Dang, that work. This would just be reverting a PR or something. But okay, so this is the old setup. This should still work. Yep, cool. But now we have a second cache where we cache basically the number of moves to get to a certain position. So it'd be map lights integer min dist equals new hash map. Right, it's like if we're already past that, then we can stop. Oh, but how do we possibly how do we record this number? No, I think that this works. So min dist dot put lights new no 0. And then we pass in min dist map lights integer min dist. Cool. So we do if min dist dot contains key for new lights and min dist dot get new lights is less than button sequence dot size, continue. Okay, but now how do we actually add in all the min dists? Otherwise, well, no, we just add to it, right? Min dist dot put new lights, comma, button sequence dot size. Is that right? We might need to do this. Yeah, I think we do +1. See how this goes. I mean, it works. Does it work without the +1? Oh boy. I guess we try both. Well, it looks like it's getting somewhere. 1 is crazy, no? What do you mean 1? Oh, 1, 3. It is 1. Yeah, I mean, this is slow as balls, but hey, at least we're getting there. I mean, the average only is like 3. 4? I don't know. The average seems very low. So this probably means we're almost halfway done, which is good. I am really just an expert coming up with the most stupendously slow solutions possible, apparently. I think maybe the issue is I'm DFSing, where the smart approach would be BFS. Yeah, that's probably it, honestly. Oh my gosh, wait, yeah, BFS would be so much easier, no? You just have a queue of lights, apply all of them, added. Oh my goodness, yeah, this is crazy. Oh well, this solution should work as well. If performance matters for part 2, I will adjust accordingly. But like, surely this is almost done running. But yeah, no, BFS should always be better than DFS here, I think. There's no need to like exhaustively prove that hitting the first button fails before moving on to the second button. We just try all the buttons. Luckily, I mean, the numbers are so small that I think it's very likely we'll get there. Also, classic problem. The procedures were eaten by a dog. Good stuff. Man, I am curious what part 2 is. I mean, part 1 is already not trivial. I mean, apparently it's not bad. I think I'm just having an issue with it. Like 2,000 people have solved this problem. Again, I think in like Python or something, there's just equation solvers, because that's effectively what it is, right? Like you have, you know, A, B, C, D, E, F, right? And you need to do like A times button 1 plus B times button 2, blah, blah, equals some end state. You end up with a bunch of equations. I think you end up with n equations for n unsolved variables, and it should just be done. Could be wrong. There might be n plus 1 variables. There probably is, honestly. I'm surprised it's not done. I feel like there's like most of these numbers are small, right? Like 4, 2, 1, 2, 3, 5. Okay, I guess there are some 5s, so but still it should be almost done. I mean, there's the input's not that big today. It's 155. So assuming, I don't know, the average is 3 to 4, we'd expect like 450 to 600. Yeah, we should be pretty close. But yeah. Probably when I rewrite this solution on GitHub, I will use BFS. Unless part 2 is something that like completely shifts it and I need to do this anyway, then maybe I stick to it. But otherwise, probably doing BFS. Okay, let's think about this joltage thing. What could these numbers mean? 22, 31, 23, 55, 31. How many? Wait, so there's 1, 2, 3, 4, 5, 6, 7, 8. Is it 8 joltages? 1, 2, 3, 4, 5, 6, 7, 8. Oh, I wonder. Oh, I know it's gonna be. You have to hit it that many times. Yeah, for sure it's gonna be that, right? Because, no, wait, no. But if you hit it this many 35 times, it should be on, not off. Dang, I thought I was on to something. Maybe it's like the minimum you have to hit it? Like you have to hit each one at least that many times? Oh boy, that sounds incredibly painful. Oh, I'm also just really stuck on them, apparently. Probably a longer one. Maybe like you. I'll give it a bit longer though. I mean, it's been doing well so far. I think it will succeed. Okay, but assuming this is, let's just try to guess part 2, right? Because I'm just waiting for my code to run. Assuming these are the minimums you must like flip each light. What does that imply? I mean, if it was an equation solver, you just plug in those as constraints, right? Like x greater than 22. But without that, I think it's still BFS. Like, does the set grow too quickly is what I'm thinking? Because like I'm putting a lot of buttons in, right? But like I'm also going to be deduping a lot of buttons, and I can parse out invalid buttons as well. I don't know. BFS might be too slow. We'll have to see. I think it's worth a shot though. And what is going on with this solution? Hello? I might just start coding the BFS version, honestly. Like, because I don't remember how to do it exactly. I haven't done BFS. I do BFS once a year, and you can guess that when that once a year is. Just whenever there's an Advento code problem that requires BFS. So let's try. So I have a queue of lights. What are you, candidates? Priority queue? I don't know what kind of queue I'm aiming for. I don't think I want a priority queue, right? Do I want a party cube? Sure, why not? And candidates dot add lights. Oh, I should definitely also just have a int storing buttons pressed. It'll just be around. Now what I can do is while candidates that is empty, sorry, well not candidates that is empty. What do we do here? Lights candidate equals candidate. Oh, nice. It started moving it. Pop that poll. Sorry, I don't even remember all of them anymore. And then for button, and buttons, lights new candidate equals new lights candidate dot lights, new candidate dot apply button, candidates if candidates does not contains 390. Let's try 390 before we keep going here. Nice. Alright, what is part 2? Each machine needs to be configured to exactly the voltage level. Below the buttons on each one is a big lever you can. Okay. So it is what I guessed, kind of. I thought it'd be at least this, but it's exactly the same. We just ignore the first one. Cool. I mean, that's pretty easy to do. Because, I mean, this is just already a lights thing, right? So we can do lights goal equals new lights. Oh, not quite. It's almost right. It's almost in the right form, but it's not quite in the right form. Dang it. Parsing. So what we're gonna do is for how do I do this in a smart way? Let's have string end equals line dot length minus 1 dot substring 1 comma line dot length minus 1 dot length minus 1. What a ridiculous thing to write. And then we do for string s in end parsing dot add, oh my goodness, integer dot parse int s. Cool. And then we do lights goal equals now int array parsing equals new int array line dot length minus 1 dot length minus 2. Sorry, I'm like trying to focus a little bit, so I'm not talking as much. It's also a little bit late, but yeah, let's see. It's parsing. Okay, so now we have a goal. So we can just do if candidate dot equals goal, return candidate dot buttons pressed. Otherwise, we kind of just keep adding. Okay, look, we already know I'm not getting it immediately, so let's go to the example. If not candidates that contains new candidate, then new candidate dot buttons press plus plus candidates dot push. Nope, dot. How do I add? Oh, add. How do I add? I say. Wow, that's a tough one. New candidate. Cool. Let's run it. It's not comparable. Okay. I see. What if I use a different queue? Array dequeue? Well, that's not a good sign. Oh, right. I should also do a check for impossibility. And possible. So like new candidate dot possible goal. What we're gonna do is have public boolean is possible. Is it is possible or is possible? I already forgot. Dot possible. Like possible. Lights other. Basically what we do is we just check each position. What? Well, surely the lights are the same length. What do you mean? They are not the same length. Why are there... What? Is there empty space? No. How did you end up with... What? Wait, that's so crazy. Oh, wait. Line dot split on comma dot length. Okay, now we at least have arrays of the same length, which is something. And now let's take a look at candidates. Boy, oh boy, do we have a lot of candidates. I mean, they look distinct. How many candidates is this? 1, 2. Oh crap. Wait. Boolean else lights be plus plus. Cool, now where do we use apply? I'm just gonna comment out helper. Oh, what'd I do? Okay. Nope. I use apply somewhere else. Oh yeah, let's get rid of that as well. Still looking like a lot of ones, huh? Alright. Here, if part 1, return empty string. Just bypass part 1. Well, that's not a great sign. Buttons press 0. Oh, also we're supposed to start with the empty set. To change a lot of code to make it work for both parts. Let's do this. If not part 1, lights.0. So now what is 0? Well, public void 0 for int I equals 0. We are literally going to 0 everything. Crazy stuff, huh? Yeah. Okay. We're getting somewhere. No, wait, break. Okay, so somehow it's going through all this. Here, let's have the toString also return buttons pressed. Oh, wait, that's it right there. Okay. New candidate dot buttons pressed equals candidate dot buttons pressed. 33, is that right? Nice. Okay. Now we go. We don't go. We remove many print statements. Oh boy. We're back to being far too slow. Love that. Okay, look, I'm just going to do some code cleanup in the meantime. How big are the numbers? Yeah, it's a disaster. That is a disaster. It's all good though. Let's think a bit. Let's try part 1 actually real quick. Does BFS work for part 1? Not in the slightest. 49. How are we returning at 0? Huh? Well, that's just confusing. the sets are clearly different. How are you getting 0? Oh. Okay, well, at least we're getting 390 very quickly now. So we've sufficiently sped up the first part. The issue is the second part. Yeah, this seems unlikely to finish anytime soon. Let's do a quick guess as to how many buttons we're gonna need to press for the first one, huh? We've got 21, so this is 53, 76, 131, 162, 191, 226, 226, 262. I have no idea if what I just said was right. 262, let's say, roughly. And on average, we see like 4. So we're going to need 262 divided by 4. We're going to need around 60 button presses. And we're at 9. That is a bit problematic now, isn't it? And the issue is, of course, the candidate set grows exponentially. Because we have 8 terms. So, you know, if we're only considering 0 and 1, it's like 2 to the 8th. But if we're considering numbers up to 30, we're now at 8 to the, no way, 30 to the 8th? Oh boy, 30 to the 8th. Yeah, I don't know if we're able to do that. Alright, I have faith that my solution would eventually work, but I also might have to wait to the heat death of the universe, so maybe we go back to the drawing board a little bit. BFS is indeed much faster than my old solution. The issues were still multiple magnitudes away. I wonder if we could sort on... This is definitely just a solver, right? Okay, I'm just gonna look this up actually. Does Java have a Z3 solver tool? I have to add the library. I don't really want to move a jar. It's quite unfortunate. Okay. What do I even search up? Like simultaneous equations? Java solving simultaneous linear equations. Apache Commons Math. done Gaussian elimination before. Took a whole linear algebra class about this stuff. The issue is, how do I do this in a realistic way? Man, I really don't want to do Gaussian elimination. I mean, I might have to, but I'd really rather not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of buttons is interesting, right? It doesn't even work actually, huh? I just realized, because there's more buttons than lights, so you end up with 10 possible things, but only 8 constraints. Yikes. Maybe it's not that trivial. What else is there to attempt? Yeah, no, I'm kind of stumped. Like, I just feel like it's not a particularly tough problem, I guess. I'm just massively struggling. Yeah. Okay. I hate to do it for 2 days in a row, but like, I think I'm probably just gonna have to take some time off camera to try to figure this out, focus a bit more. It's tough. This kind of problem always happens. Like, I feel like there's been other years as well where it's just felt like there's some simultaneous equation thing, and I just am not well equipped in Java to know how to solve it. Like, I've solved so many by paper, so many with matrix solvers online, but yeah, not really sure how to do it easily in Java. So yeah, I mean, apologies again, but it's going to be another only part 1 day. At least today's part 1 I think was actually somewhat interesting. It was not trivial, so hopefully you did manage to learn a little bit there, even though, obviously you didn't really learn much for part 2. But yeah, see you tomorrow for the second to last day.